Now we will start our discussion on chi-square distribution. So before I can start my discussion of this chi-square distribution and test based on chi-square distribution, first it is necessary to understand what is actually meant by chi-square variate. So suppose if x follows normal with mean mu and variance sigma square, so that means my parent population is normal distribution, then we know that x minus mu by sigma follows normal with mean 0 and variance 1. So that means it is a standard normal variate. And what is chi-square variate? Chi-square variate is square of a standard normal variate. So if I square a standard normal variate, so I will be getting a chi-square variate. So first we need to test for the population variance. So the first test in chi-square distribution is test of population variance. So that means my null hypothesis in this case is sigma square equal to some specified value of population variance, that is sigma naught square. So since my under population, so the population under consideration is normal with mean mu and variance sigma square, and I want to test my hypothesis of two-tailed test. That means my alternative hypothesis is sigma square which is not equal to sigma naught square. So that is my two-tailed test. So there may be two cases. In case 1, when my population mu is known, and in case 2, when the population mean is unknown. So now we will start our discussion on when I am testing h naught as sigma square equal to sigma naught square, but the population mean in this case is known. So that means mu is known. Suppose if I have some xi's, be a random sample drawn from the parent population. So x follows normal with mean mu and variance sigma square. So therefore xi minus mu divided by sigma follows normal 0, 1. And if I square this, so if I square this, so that will be value what? So summation xi minus mu square divided by sigma square follows chi-square with n degrees of freedom. So since I am adding all the sample values, so therefore the degrees of freedom becomes n. Suppose if only one variable is there, x is there, then x minus mu square divided by sigma square follows chi-square with 1 degrees of freedom. So now what is my test statistic in this case? Since my h naught is sigma square equal to sigma naught square, since this value is known and mu and sigma square are the parameters of normal distribution, so out of these two, one parameter is known, so sigma square is known and mu is unknown. So therefore for chi-square, my statistic becomes, test statistic becomes summation xi minus mu square divided by sigma naught square follows chi-square with n degrees of freedom. So calculate this value. First we need to calculate this value, and then I want to compare this with chi-square n degrees of freedom. This is my table value and this is my calculated value. So what is my rejection region? My rejection region becomes if chi-square greater than chi-square n alpha by 2, since it is the two-tailed test, or if chi-square is less than or equal to chi-square n 1 minus alpha by 2 equal to alpha. So if the probability of this value is equal to alpha, this is my rejection region for two-tailed test. And for right-tailed test, suppose if my alternative hypothesis is sigma square greater than sigma naught square, then my critical region becomes probability of chi-square greater than or equal to chi-square n alpha equal to alpha. And in case of left-tailed test, my alternative hypothesis is sigma square less than sigma naught square, and then my critical region becomes probability of chi-square less than or equal to chi-square n 1 minus alpha equal to alpha. So in case of only one-tailed test, my level of significance becomes alpha, but when it comes out to be the two-tailed test, my level of significance, since I am taking both the tails, so it becomes alpha by 2, but the total level of significance is alpha. So how to conclude this test? So if my calculated chi-square, is greater than table chi-square, if you take this as then H0 is rejected for right-tailed test. And if calculated chi-square is less than table chi-square, if my alternative hypothesis is sigma square less than sigma naught square, then that should be, so we have to accept the null hypothesis, otherwise reject it. So the rejection region for two-tailed test, is chi-square greater than chi-square n alpha by 2 or chi-square less than or equal to chi-square n 1 minus alpha by 2. Otherwise we can accept it. And for the right-tailed test, if chi-square is greater than this value, then we need to reject the H0. And if for the left-tailed test, if chi-square is less than chi-square n 1 minus alpha, then I need to reject the hypothesis. Otherwise, what we have to do, we have to accept the null hypothesis. And since we know that chi-square distribution is not symmetric, therefore we can use equal tail criterion. So that means we are taking area of each tail is taken to be alpha by 2. And the value of chi-square, that means the test statistic, in this case is always positive. And what happens if I take the value, of mu is supposed to be unknown? So if the value of mu is supposed to be unknown, in that case we need to replace the value of mu by x bar. So therefore my test statistic in this case becomes summation xi minus x bar square divided by sigma square, and the degrees of freedom in this case is n minus 1. See, earlier my degrees of freedom is n. But in this case the degrees of freedom is n minus 1. So why this is n minus 1? Because 1 degrees of freedom is lost, since instead of taking this mu, now I am taking this as x bar. Therefore we need to subtract 1 degrees of freedom. So the test statistic in this case becomes summation xi minus x bar square divided by sigma naught square follows chi-square with n minus 1 degrees of freedom. Only the difference between these two cases are, the earlier case when I know the value of mu, but in this case I do not know what is the exact value of mu. In this case mu is unknown. Therefore only the difference is, instead of mu, so I am replacing this mu by x bar. So what is my critical region? The critical region for two-tailed and right-tailed test is probability of chi-square greater than or equal to chi-square n alpha equal to alpha, and for two-tailed test this probability of chi-square is less than or equal to chi-square n alpha, which is equal to alpha. And what is the conclusion? If calculated chi-square is greater than table chi-square, H0 is rejected, otherwise it should be accepted. So this is the first test which is based on chi-square distribution. So we will discuss few more tests in the next lecture. Till then, goodbye.